Alright, hey guys, we're entering into the first of the few new concepts that we're going to learn this unit. Hopefully you've had some good successes so far with the stuff that's a review from Algebra 1 and Geometry. Today we're talking about the law of sines.
So the law of sines states that an equation used when given a triangle with ASA or AAS to find a missing side length or angle measures. If you recall, ASA is angle side angle or angle angle side.
So the big thing we want to remember is that the triangle does not necessarily need to be a right triangle, because that's why we have these. Otherwise, if it was a right triangle, you could use regular trig, but because they're not right triangles, which this would work with right triangles, but this is how you use it in order to find your missing information. So you just have to have two angles in the included side or two angles and a side.
And the equation states like this: sine A over A equals sine B over B equals sine C over C. Or we can have A over the sine of A equals B over the sine of B equals C over the sine of C.
It's really a personal preference. You can use whichever one you want. Most people I know throughout the years that I've been teaching this use the first one because having that sign on top just is easier for them, but it really depends on the person. You will not use all three of them at once. You will only use two of them at a time and set up a proportion. So, for example, you could use this if you're missing either angle A, angle B, side A, or side B. So, this is all in reference to this triangle. Remember, side A is opposite angle A, side B opposite angle B, side C opposite angle C. Yes, I know that this picture I've shown you is a right triangle, but you don't really know that because it didn't mark it, therefore C could be 89 degrees. So let's take a look at an example. Here we have angle AB, triangle ABC. We need to find side length B, which is really side length AC, side length C, and the measure of angle C. We're going to start with angle C because we can use triangle sum theorem. So if we take 180, sorry about that, we take 180 minus the sum of 40 plus 49, we will get our measure of angle C. So we're going to use a calculator. We're going to take 40 plus 49, and we get 89 degrees. Then we take our 180 minus 89, and we get 91. So the 91 degrees is the measure of angle C. Now we need to find the other pieces. So we know that angle A is 40 degrees, so we're going to take the sine of 40 degrees. Well, that is opposite the 20. And then let's start with finding B. So that means we have the sine of 49 degrees over B. Some of you might try to do some of this in pieces. Personally, I would like to see you solve for B long before you ever get to the point of putting it in the calculator. It makes your life a whole lot easier. So when we cross multiply, we get 20 times the sine of 49 equal to B times the sine of 40. Well, we have to solve for B, so we'll divide by the sine of 49, or sorry, sine of 40, to cancel these out. So that means that B is going to be equal to 20 times the sine of 49 over the sine of 40. And no, the signs do not cancel each other. So now we go over to the calculator. We check to make sure that our mode is in degrees, because otherwise we will get completely wrong answers. Quit out of that, and we put this in the calculator. The numerator, 20 times the sine of 49 divided by the sine of 40. And we get, we'll round to the nearest tenth. That tells us that B is equal to 23.5 approximately. Now we have to go back and repeat this process. The key here is to remember you don't want to use B for one of our values to set up the proportion simply because we found that. And just like we've talked about previously, if you use something you found and it's wrong, you're kind of screwed. You can use the 91 though because that is exact. 23.5 is also rounded. So once again, I'm going to use the sign of 40 over 20 because that stuff was given to us. And then we can use the sign of 91 over C. Doing a shortcut, we know that C, once I cross multiply and divide, I'm going to end up getting that C is equal to 20 times the sine of 91 divided by the sine of 40. So I go back over here to the calculator and I say 20 times the sine of 91, and I'm going to get a value for that since I didn't put parentheses in, and then I'm going to divide that by the sine of 40. And I get 31.1. So C is equal to 31.1. So yes, these problems are a little bit more involved. So you have to make sure that you're doing things, and you're going to have to make sure you're showing all of your work. Next thing. Here we have an example in which we have a triangle in which we need to find the measure of angle C, but we only have one angle given. So we start by labeling all the figures in our problem. It says the measure of angle A is 32 degrees. It says AB is 8 and BC is 5. Especially if I don't give you the picture pre-printed, you will want to label simply because it'll make your life easier to figure out what it is you're trying to find. So we want to find the measure of angle C and side length AC. So we start off here, we need to have two angles in order to find a side, which means that I'm going to start off by finding that angle measure. That means that the sine of C, which we don't know, is over 8, and equals the sine of 32 over 5. When we do our cross multiplication, we get 5 times the sine of C equals 8 times the sine of 32. We then divide by 5, but then we still have the sine of C equals 8 times the sine of 32 over 5. We need to get rid of that sine, and if you recall from trig, in order to get rid of a sine, you need to take the inverse sine, which means that the measure of angle C will be equal to the inverse sine of 8 times the sine of 32 over 5. So I put in here second sine, 8 times the sine of 32 divide by 5. We hit enter, and we get 57.98. 57.98 degrees, which if you round to the nearest tenth of a degree, gives you 58 degrees. So given that this is 58 degrees, in order to find side length AC, we need to know measure of angle B. So that means we're going to take 180 minus 32 plus 58, and 32 plus 58 gives us 90. That tells me that the measure of angle B is 90 degrees. I know it doesn't look it, but that's why you can't go based on proving by picture like we talked about back in geometry. So now we can say that the sine of 90 over B is equal to the sine of 32 over 5. So when we do our cross multiplication, we end up with 5 times the sine of 90, and we're going to divide it by the sine of 32 to get our b. We come back over here to the calculator. We take 5 times the sine of 90 divided by the sine of 32, and we hit enter, and that is not correct because notice where I forgot parentheses. So 5 times the sine of 90 gives us 5 because the sine of 90 is actually 1. And we divide that by the sine of 32, and we get 9.4. So there you have it. The next part is finding the area of a triangle when you can't use base times height because we don't have the height. Base times height divided by 2, sorry.
So then we would have area equals 1/2 c times b times the sine of a. Or you could have area equals 1/2 c times a times the sine of b. Or the last one would be area equals 1/2 b times a times the sine of c.
So basically what that means, we need to have 2 sides and the included angle to be able to find the area. So these formulas are all basically the same thing. You take the 2 side lengths you're given with the angle in between, and those are the ones you're going to use. So for example, we're not going to solve this one, but you're going to have here, because I got 4 and 8 and 23, area would be equal to 1/2 times 8 times 4 times the sine of 23. And that would be how you would calculate the area. So let's go ahead and try that on this problem.
Before we get to that, could we do 8 times 4 times the sine of 23 all divided by 2 and get the same answer?
Absolutely. Absolutely. Good, excellent question. Here, for this problem, the one thing we need to remember is it needs to be the included angle, and that is this angle here. So before we can actually find the area, we need to go ahead and take 180 minus the sum of 65 plus 55. So then if we come over to the calculator, 65 plus 55 gives us 120. 180 minus 120 is 60. So this is 60 degrees. So our area is going to be 1/2 times 132.8 times 120 times the sine of 60. So we come over here and we put that in the calculator. 0.5 times 132.8 times 120 times the sine of 60. And we get an area, yes, these should be bigger, of 6,900.5 meters squared. And yes, I apologize for the length of the video, but there was a lot of content to cover. So now we've got a job for you. Here we go. We got 2 problems here. The first one, you're going to solve the triangle. That means I want you to find the measure of angle B, side length B, and the side length A. And then for E, I want you to use that 8 feet, 12 feet, and angle of 86 degrees, and find the area of the triangle. Round all of your answers to the nearest tenth. And as always, bring your questions with you